Welcome, everyone. I hope so far you have been enjoying a great tech day at AdaCore. My name is Felix. I'm a system and software architect at Nexperia. Today I will give a presentation about REJUVENATION. That is a library that we use internally within Nexperia in order to do code refactorings and save money.
Refactoring with confidence, a pattern-based approach built on top of LibAdaLang to save you dollars. As already said, today I will give a presentation about REJUVENATION. And walking you through the presentation, we have 5 agenda points. First, I would like to give an introduction about ITEC. This is a sub-company of Nexperia that I'm working for, and how we use Ada in order to build equipment and automation technologies. In the second part of the presentation, we will take a look at analyzing code using AdaCore technology, in particular GNATcheck and CodePeer. Then we will take a look at LibAdaLang, which is also an offering from AdaCore, and how we extended LibAdaLang with our own technology called REJUVENATION in order to come up with an approach to do automatic refactoring. In the fourth chapter, I will guide you through some sample refactorings that we did using the REJUVENATION library. And at the end, I would like to make some conclusions and draw some next steps, how we think REJUVENATION can be evolved in the future. Taking a closer look at my company, ITEC. ITEC itself has been a department of Philips, later on NXP, and now Nexperia for over 30 years now. And recently, since this year, we are on an exciting journey as an independent company within the Nexperia family. We have over 150 employees. Part of our competence is in Nijmegen, which is in the Netherlands, and part of our competence is in Hong Kong. In the top photo, you can see our office building in the Netherlands. And if you want to visit me, then this is where you have to go. What we do within ITEC is we build machines for the assembly and test processes in Nexperia's backend fabs for the semiconductor production process. And we have already an installed base of more than 2,500 systems to fuel the production in Nexperia, where we produce over 100 billion pieces per year. We also have a special offering for factory automation, which is called ADACORE. And to this tool, next to our 2,500 ITEC machines, we have also connected other machines, summing up to a total of 3,700 machines. So what are these machines now? Basically, we can split them up into 4 different product categories. On one side, we have our ADA3 assembly platform. This is a type of machine that we use in our assembly processes, where we do wire bonding or die bonding. Then next to that, we have our parser test platform. This kind of platform is used to test our semiconductor devices before they leave the factory. Next to that, we have our inspection platforms. Those kind of machines take images of the semiconductors and inspect them for failures like chipping. And last but not least, we also have a software-only solution, which is called ADACORE. That is a solution we do apply in factory automation scenarios where we want to connect to many machines doing the typical SCADA activities. Looking at the technology that we use for software development, we have been almost one of the first customers of AdaCore. We have been using Ada already since '94. Our customer account number is actually 201. We do have only a few software developers though, but still we are able to support a rather huge code base, which is close to 1.5 million lines of Ada code. Next to that, we also have some parts implemented in C++ and C, where we do, for example, integrations with external libraries like OpenCV, where there is no equivalent available in Ada. Our machines run on typical Windows systems, and this is also the most common platform that we target. These days, of course, everything is 64-bit. Recently, we have also been exploring ARM solutions because we are splitting our system up into distributed systems where we have a central computer running Windows operating system, and then with an Intel CPU, and then the satellites of the system, we do have small ARM processors running on FPGAs. Our development environment is also based on Windows. And if we look at what kind of technology we use from AdaCore, then many of the AdaCore libraries we are actually using, like for example, GNATcheck we use, but also AWS, the Ada web server. This is one that we heavily use, especially in the automation scenarios where we want to do connectivity with our machines. But as our code base is already so many years old, we are also facing problems like technical debt and legacy. And the question that raised over the last years is, how can we actually deal with these kind of legacy? What can we do about it? Can we improve our code base? Can we improve our way of working to work even smarter? And for this, we joined a cooperation with TNO-ASI. That is a research institute in the Netherlands that supports local technology companies with their software development efforts. And they provide us with tools, but also with processes to improve our way of working in terms of software. On the right-hand side, you can see a screenshot of our code base. Here I tried to give you a nice example how we are already using Ada 2012 code, where you also can use the pre and post conditions on your procedures. In the next chapter, I would like to walk you through doing code analysis with GNATcheck and CodePeer, because those are important tools in our software development process to check the quality of our tools so that we can make sure that no bugs are going to the customers. We will shortly take a look at how we apply GNATcheck and CodePeer within ITEC on our codebase. We will show you results that we did when applying those same settings on AWS as well as on our own codebase, and then come to a conclusion, what do we actually observe when we apply them. The GNATcheck and the CodePeer settings that we apply are the following. For GNATcheck, basically we enable everything. On this slide, I only show those parameters, though, that do require special adjustments because they also have parameters that you can give with the options. But also all the other options where it is just a Boolean yes or no enablement, and this is also what we do. For CodePeer, we apply level 1 on our own code base and level 4 on AWS. This has more or less to do with the performance impacts that it's having if you're applying level 4 on a huge code base. It just takes too long to analyze this. We have a CI/CD pipeline, and we basically run this on Jenkins. And if, as a developer, you do a commit, then in the background, we will execute GNATcheck and CodePeer automatically. And the results that are gathered from those tools, they end up in SonarQube, where we can display the results over time. In the next slides, we will show you some of the numbers that we got from those tools. And we will present those numbers in terms of total counts, but also in terms of how much effort will it take to solve all these findings. And for this, we took a metric from AdaCore, because when they do the translation from GNATcheck and CodePeer to SonarQube, they also give for every finding an indication in terms of minutes or hours, how much effort it would be to solve those findings. Now we will take a look at the analysis results for AWS. On the left-hand side, you see the numbers for GNATcheck. On the right-hand side, you see the ones for CodePeer. And each graph features two numbers. So the total number of findings, as well as the indication of effort that it needs to solve them. And what you can basically see, this is a Pareto analysis of the findings. In GNATcheck, we have a lot. In CodePeer, this is less. But still, looking at the pure numbers, in order to solve those findings, it will be a lot. Probably more than we can ever do. Looking at the x-axis, there you can see the kind of findings. And then you can make up your mind what kind of findings are something where you need to take a look more closely, or what kind of findings you can potentially solve automatically if you had the tool available. If we look at the same analysis for our own code base, basically we end up in a similar scenario. We have a lot of findings, even more, but also our code base is much larger. But also here, the effort is just too high to solve them in a reasonable amount of time. Let me draw some conclusions here. So if we look at the CodePeer findings, basically what we can see is we do have a lot of findings, but these kind of findings are not ones that you can easily solve automatically, because you really need to deep dive into the code, get an understanding if this can be solved at all, if this is a bug, what is really going on. So for those kind of findings, we think this is still engineering activity that needs to be done. For GNATcheck, on the other hand, we see that some number of findings, they are actually easy to solve if you have some kind of automatic tooling available. Things that come up to our mind are, for example, the findings on non-short circuit operators or binary case statements. Those are just patterns, and patterns, they can be detected by a program and then also be fixed by a program. But some other findings of GNATcheck also require engineering activities. So for example, if a package has too many dependencies, this is still something where you as an engineer want to dive into and check where are these dependencies now coming from, and can I give better structural design to my code to have less dependencies. So the question now is, if we already have an indication for some items that can be solved automatically, how do we do this? And this is where we came up with the rejuvenation technology. But before I will give an introduction to rejuvenation, I would first like to introduce LibAdaLang. This has also been presented in one of the tech days, I think it was 2 or 3 years ago. And since then, this technology has been matured. LibAdaLang itself is a library offered by AdaCore, and AdaCore also switches more and more of their tooling to LibAdaLang instead of ACEs. What this library offers is an access to the syntax tree, so to the AST of the Ada language, and it also has experimental support to rewrite code once the syntax tree is understood by the program. You can access LibAdaLang from Ada, but also from Python. What we do see though is LibAdaLang is more base library with a lot of power, a lot of features, but you need to be a language and compiler expert to work with it. For the normal engineer who is just concerned about the quality of his own code, it is too heavyweight to use it easily. But we see the potential in this library to make these kind of transformations that we have been talking about on the earlier slides. So what is now rejuvenation? Rejuvenation is a library that has been developed by GNATcheck, and it extends LibAdaLang. It builds another abstraction layer on top of LibAdaLang so that you can have searching and handling of the search results in separation, and that you can do complex subtree matching by supplying patterns to the rejuvenation framework that then rejuvenation will apply to your source code. And the beauty about this concept is the patterns that you give to the rejuvenation library, they just look like Ada code. So if you are able to write Ada code, then you will also be able to write patterns that rejuvenation can understand, and that rejuvenation can then match to your code. So find those patterns in your code base, and in a later stage also do rewriting based on these patterns. So here in this slide, I give you an example. On the top right, you see Ada code, just a standard if, else, and if construct. And on the bottom part of the slide, you see how this can be matched to a rejuvenation pattern. And the only difference that you see is that we have these dollar tokens at the beginning of the condition or the variable. But for the rest, it just looks like Ada code. This also has the advantage over, for example, refactoring using regular expressions, that this is really tightly bound to the AST. Regular expressions, they not have a deeper understanding of the syntax of the Ada language. So probably you will only be able to find constructs on one line, because this is how regular expressions work. But with rejuvenation, it doesn't matter how you format your pattern. Because the pattern also is part of the AST, we can match it to the AST in Ada. I would now like to present some sample refactorings. If we take a look at the findings of GNATcheck and CodePeer that we had earlier in this slide, we will have the example of the binary case to if statement. So if you have a binary case statement where you have a case that is only switching between 2 branches, then this can also be translated to an if statement. And I will also give you an outlook what else we already have in our own rejuvenation packages. The example case at hand is the binary case to if statement conversion. On the right-hand side of this slide, you already see the final check-in that made it into our SVN repository. But in order to come to this final check-in, this was actually a multi-step process. And I will walk you through the steps of this process. So in the very first step, what we did was we simplified all the binary case statements. This first means we need to detect all the cases that we have in our code base where we have a case statement that looks like a binary case statement. So we have, for example, the case where we have the expression part. Then we have multiple value statements, but this is only one, of course, because we're talking about binary case statement. And we have an others branch. This one can be translated to an if with a true and a false branch. Then we have the case where we have null branch within the case statement and only statements in the second branch. This one can of course be translated to just a simple if statement. And then we have the case where we do have two statements and they are translated to an if statement. But in this case, we know that this is actually referring to an enumeration type. And we want to make sure that if a new value is added to the enumeration type, that we are not introducing some path in the code that the compiler didn't know of. Because this is a feature that the GNAT compiler does if it has an enumeration type in a switch case statement. That it will also check if all the cases of the enumeration are actually touched. This is something that you cannot do in an if statement. This is why we add the assert statement at the beginning to make sure that all the cases of the enum type are actually in the code. In the second step, we do simplify the if statements. So you can see that sometimes we have explicit conversions from a condition to a return true or return false, but of course these can be reduced to just returning the outcome of the condition. And we also see cases where we do have an if branch, but an else branch with a null statement. Then of course you just want to get rid of the else statement. And then in the later step, we will also simplify all the conditions. So for example, remove unneeded brackets and also simplify double negations, these kind of things. And in the latest step, we also do pretty print of the changed code base, of the changed code sections. And this we do by running GNAT pretty printer on the code, but we also use the pretty print on, pretty print off comment statements so that we only touch those parts of the code that really have been changed, because the unchanged parts we not want to touch. Otherwise, we would lose the history in SVN. Next to the sample refactoring that I just presented, we also already did other refactorings on our code base. Not only based on what GNATcheck and CodePeer actually reported, but also on the observations that we had ourselves. One of the things still coming up from GNATcheck was fixing the short circuit operators. This I will explain in more detail on the next slide. But what we also did as an example was converting the old 4x tick address use statement into the new ADA 2012 aspect notation. We also convert several statements with booleans into simpler statements. Yeah, so if you explicitly convert the condition to a return true or return false, as I already said, you can just return the outcome of the condition. Double negation we fix. We fix not A in some range into A not in some range. And then of course also getting rid of unnecessary else branches. We also fix assignments to unbounded string, to just calling set unbounded string, because we are always trying to find opportunities to make our code even run faster. So those are things that we think also outside of ITEC have value to other users of Ada. And then we have some very specific Ada ITEC refactorings. So what we did was we removed unwanted log statements from our code and we added wanted log statements. This is something we can use the rejuvenation library for, but probably this is not generally applicable to all the code bases that are existing outside of our company. At the beginning of the presentation, I also gave the promise that rejuvenation will also help you saving dollars. So what did we observe in our own code base? And where did automatic refactoring already pay off? In the case of the refactoring of short circuit operators, this is converting from and or to and then and or else. This is something that we saw a lot in our code base because typing and typing or is faster for the developer, so they not type and then and or else, even though this would be faster in the execution. And as I already said, this is something that we always aim for. So we wanted to fix all those cases, and then we will also get rid of all the findings from GNATcheck. If you take a look at the hours that actually come out of GNATcheck in order to fix all those warnings, that would have been already $300K engineering effort to fix them. But with rejuvenation, we were able to fix them just in a matter of weeks. And it was not because rejuvenation took so long to convert all our code, but we also wanted to do some reviewing because this was the first activity that we ever did using rejuvenation on such a large scale. But if you have the confidence, and that we now have, you can also just commit them in one step, and then you will have all these changes already implemented in a very fast amount of time. If we take a closer look at the other findings of GNATcheck at our code base, we can guesstimate that we can save another $900,000 when we fix them automatically. On the other hand, what did it cost to implement rejuvenation? And there we see that this is a lot smaller than 100K. Of course, this assumes that you already know LibAdaLang. You first have to build up your knowledge in LibAdaLang and then build rejuvenation on top of this. Then you have to spend more effort. But if you are professionally skilled in LibAdaLang, then adding the functionality of rejuvenation on top of that is not that expensive. I would like to get to the end of the presentation to draw some conclusions and also discuss some next steps. We do see that AdaCore already provides tooling like GNATcheck and CodePeer to analyze code bases, and those have been proven to be very useful to find bugs in our code base before they go to the customer. We also see that AdaCore within their compiler technology has options that you can enable, for example, the style checks, to enforce this even before the code is compiled. But this does not hold for all the rules. So in that sense, GNATcheck and CodePeer does more as the compiler. We also see that many findings can automatically be fixed if you have the right tooling at hand. LibAdaLang is a technology that you could use to do these kind of refactorings, but it's not that easy to apply. You need to be proficient in that library. You need to be a language or compiler expert to use it properly. So the gap for the normal developer is just too big. But using rejuvenation, we have been able to enable our normal developers to also do these refactorings and then still be confident that all the changes that they apply to the code are doing no harm. And we even see that this can also save us dollars because saving all these findings manually takes a lot more time than just applying the pattern-based approach of rejuvenation. So from our perspective, we think there is actually an opportunity for AdaCore to offer a product next to the analyzers that they already have that not only find the smells in the code, but also fix them already. We also think that there's an advantage if you want to migrate old code bases to newer versions of the Ada standard, like going from Ada 95 to Ada 2012, make the code more accessible to the current engineers, but also to future engineers that you plan to hire. And there has been a joke, April the 1st joke in the past, was on the AdaCore blog, where it was said there will be a modern syntax for the Ada language coming soon, very close to C. Also, this is possible. Using rejuvenation, you can reformat your code and transform it into a completely different programming language. So what we will do We will open source the samples that we already showed in this presentation so that you also have the opportunity to apply them to your own code base and see what kind of results you get. And next to that, to give you an outlook what we are currently doing in terms of research, we are also looking into other tools to analyze our code base. Currently, we are using graph-based databases to get an understanding of how our code base actually links together. And also from those tools, we think we can make some steps to understand our code base better and make some improvements automatically to the code base to bring our code into a better shape. And with this, I would like to close this presentation.